Hello, everyone. Welcome to Professor Messer's Network Plus study group for the month of February. We've got quite a lot going on today, so I want to thank first everybody who is joining us live. We do this once a month, and what I will usually do is put that in the calendar on professormesser.com/calendar so you can see exactly when it is that I'm planning to do this. And from that calendar, you can also sign up to be on our notification list. So I'll send you an email sometime that week asking for your questions and send you an email just before we get started. Of course, you can always follow us on Twitter or on Facebook and get the notifications there as well. My name is James Messer. I'm here at professormesser.com, and my goal today is to get all of the questions that you send me throughout the month, and then I give you some answers to those. Now, obviously, I get quite a few questions during the month, so I can't do all of them, but I try to get the ones where people are asking a lot of questions over and over and over again, and try to give back some feedback on the things that I'm seeing as you're sending them into Facebook, or you're sending them into Twitter, or sending emails. I just start collecting them. They go in my Evernote. I have huge lists of them and spreadsheets that I can pull up. There's a lot going on there. So one of the things that we will focus on during the study group are those questions. But before we get into that, I do want to let you know that this is effectively here and available because you support the site. You watch the videos, and some of you actually purchase our Network Plus group, our videos that are associated with our online course. And that's nice. You can take them around with you afterwards, take them offline when you're not connected to an internet. And we absolutely appreciate everyone who's made that investment in Professor Messer. It helps keep the site going. It helps us so that we can do these study groups. And I think it works out better for everyone when we do something like that. If you'd like to learn more about that, you can see it on our website at professormesser.com/download-net plus. Well, this is about we're going to talk today about the Network Plus exam, but as you know, or some of you may know right now, there are two Network Plus exams that you could take. There's the N10-004, there's the N10-005. So it's the 004 exam and the 005 exam. The 005 exam, relatively new. It came out on December the 1st of 2011, so just a couple of months ago. It is one where you can take the new exam, the 005, but you can still take the 004 exam as well. It's going to be available all the way through August the 31st of 2012. So there's some new things in the new exam. There's some old things in the new exam. It's a mixture of different things. Now, in a previous study group, we went through in detail what are the differences between those two exams. And if you go to the main index page for Network Plus, if you go to freenetworkplus.com, and freenetworkplus.com. It will take you to the main index page on Professor Messer, and we give you a video breakdown of exactly what the differences are in every single section of those two exams. Now, the benefit, of course, is you can take either. It doesn't matter which one you take, you still get a Network Plus certification. So don't worry that you maybe have studied for the 004, you're going to go take the 004. In fact, you can take it all the way through August the 31st. And you may be wondering, is this really a good exam to take? What if I take the 005? Isn't it a better certification? Well, functionally, there's no difference between the two. CompTIA sends you a certificate that says you're Network Plus certified. Whether you took the 004 exam or the 005 exam, you get the same certification. So it doesn't matter. Now, some people may have people in their organization that prefer that they get the latest certification. Those instances are relatively rare. You don't see those very often, but there are some circumstances around that. So check internally in your organization if you're planning to do this, if they would prefer you get the 004 or 005, or if it matters. If you're just getting the certification for the purposes of getting your foot in the door, getting an interview so that you can then wow them with your education and your experience, well, then you can take either one of these. They're looking just to see if you're Network Plus certified. So there's some things about that can be very useful to you. In this study group, if you are already Network Plus certified, you can have this session count towards your continuing education units. Many of you may be familiar with those continuing education units. If you already have a Network Plus certification, you can maintain that certification by accumulating a number of continuing education units over the next 3 years. And this is one of those that works for this. This is participation in an industry event, seminar, workshop, podcast, webinar, or conference. You can get one CEU for each hour that is spent associated with that. And you can see that you can have a maximum of 6 of these for Network Plus. Now, obviously, you need a lot more than that to get your Network Plus renewed for another 3 years. So, but this will get you at least 6 credits towards that end. If you don't have your Network Plus certification, this doesn't apply to you. Don't worry about that piece. But some folks have asked me, is this something I should think about doing? Is this one of the things I should attend, and can I use that towards renewal? You absolutely can, and that's the reference. And I put that link across the top, so you'd be able to have that reference there. Well, I just have people roll in barrels and barrels and barrels just full of your questions. And again, this month was no exception. I have tons of questions that I can pour through, that I can look at. And of course, we have the other study groups that we've been doing for a number of months now. So if you go to that same Network Plus page, either one of our Network Plus pages, you will have at the very bottom the list that is the replay for every one of our study groups. And these sometimes go on for well over an hour. So there's a lot of great content that we pack into that. It's another place you can go to get even more information across that. And as the chat room is mentioning, I bet a lot of the questions are the same. It's not 90% of the questions are the same, but boy, I do get a lot of similar questions. It's remarkable, though, just the diversity of questions that I am getting. I've done about 4 or 5 of these study groups now, and I'm getting very different questions. I'll occasionally get a block of similar ones. There's some questions you always see about subnetting. There's a lot of questions that come in about subnetting, and we'll look at some subnetting techniques this month as well. I try to touch on that every single month because there is a popular number of questions, but it may not be the question that you're thinking about regarding subnetting, because I could talk for hours about subnetting and that piece. And in fact, this month I got some very interesting questions about the way networks work. It doesn't specifically point to any specific part of the exam, but more about taking all of these concepts that you're learning about for Network Plus and applying them into how a network actually operates, which I find fascinating. So we will go through some of that. OSI model is another one that is a popular one. So the first question, I thought this was a great place to start. So if you're looking to get on the good side of me, WB, this was a good question. Where do you get your good looks? Well, I don't know, but there they are nonetheless. Now, this is a WB. That was a guy, so I'm not sure what's going on there. But, I am married. If you happen to see the every Saturday, we do our podcast of What a Week, our live broadcast that we do 11:30 Eastern Time here in Tallahassee at the Messer Studios headquarters. You'll notice that it's myself and my lovely wife. I like to say I'm married up that way. So good looks, they only go so far, actually. And when you have hair like this and lighting that you have to work out for a video, it's not necessarily the best look, I assure you. But occasionally, it works out okay. So that's one of the nice things about that. Yes, the last study group we did was about cold beer. This one's about my good looks. You can see we're degrading quickly. Let's start with, though, your questions. Let's go into the details of what you asked this week and see if we can get into those pieces. And this was a question I got on Facebook and in our chat room as well. And it speaks to these concepts that we learn about and combines a number of these together. So this question is, using TLS or SSL, which is encrypted web traffic connection, is that still safe if you're using a wireless access point connection that's unencrypted? Let's say you're in a coffee shop somewhere. So in that particular case, is that really useful? Is that good encryption? Is that something we should use? We're in that situation. Or is using WPA encryption on your wireless link, or perhaps even a VPN, something that can be used to ensure privacy? And the real question here revolves around privacy. And privacy is obviously many different connotations associated with it. When you talk about privacy on a network, you're really referring to, can someone see what I'm doing? And it may not even be anything very interesting. I always think about when people are hijacking your emails or listening into your phone conversations. If somebody listened in to my phone conversations, they would be incredibly bored, because I'm usually talking to my wife about, should I stop on the way home and pick something up from the grocery store? Oh, I need to take my son to do a band solo on Saturday morning. This is incredibly interesting things, and it would probably bore everyone. But when you're talking about networking, you're sending information all the time that could be grabbed by the bad guys and used. Think about your passwords. Do those go across the network in an unencrypted mode, or are they encrypted? Good question. And when you're on a private access point in a coffee shop, that certainly becomes a concern. So what type of encryption methodology makes the most sense? What should we do? So I thought it would be good to go through a couple of these. Now, here's the situation. Let's say we're at a coffee shop. So you can see your laptop is down here. And I've got, this is the internet, the big happy cloud. And let's say you're talking to some web servers out here. So let's first address this idea of using SSH. Or using some type of encrypted tunnel. And when you're using SSH in your browser, you go to a website and you type in HTTPS and you go to that website, you'll notice there's a lock on the screen, and the lock goes from unlocked to locked to designate that this particular link is encrypted. If you log into your Google Mail, if you log into your Yahoo Mail, you log into those types of systems, log into your bank to check your balances, it's going to put you over an encrypted connection. If you're going to a normal website, let's say you're just going out to ESPN.com, you're going to CNN, you're just looking at things that aren't very private, nobody really cares about encrypting it, that particular link is going to be in the clear. If somebody was sitting in the middle, they could grab all of your packets, they could take all of your packets, reconstruct them, and effectively build exactly the same page you were looking at. And that's done all the time. We do that with web pages. We do it with voice over IP communications. We do it with emails and messages and instant messaging. It's very, very, very simple from a security perspective to reconstruct those sessions and put them on the screen and effectively see exactly what you saw. So if you're doing any of those types of things and it's in the clear, this big green non-encrypted link to whatever that server happens to be, I can absolutely see what's going on. Now, if you're surfing over to CNN, that's one thing. You're reading the news. That may not be something you really have to be concerned about from a privacy perspective. Now, HTTPS is a little bit different. I'm going to a web server, and the instant I talk to that server, I'm going to say, look, I want this conversation to be private. So, Mr. Web Server, could we just have a conversation here between me and you, and let's send everything in a secret code. Let's encrypt all of the pieces in between and send that information back and forth. And if somebody was to sit in the middle of this and watch what was going on, they would have no idea what this looked like. It's a bunch of gobbledygook. It is a bunch of noise. If you tried to reconstruct it, it couldn't reconstruct anything. It's absolutely encrypted. Not all sites, as we're mentioning in the chat room, work using this SSL communication. If you were just to go to ProfessorMesser.com, it's not encrypted. If you were going to sign into your member section for downloading the videos that you purchased, that is encrypted because I don't want people to be able to see you sending your username and password over the network. So those are two examples of the same website, but different pages on the site. Some may be in the clear, some may be encrypted. And it just depends. Now, from an end user perspective, this gets kind of difficult to figure out, is it encrypted or not? And a good example, CoolCB in the chat room is talking about capturing the packets and looking at them. UJellyBro24 is talking about Facebook is encrypted, but is it not encrypted? In fact, there's a nice plugin for the Firefox browser. There may be one for Chrome and others as well that you can load it up and it will automatically encrypt to the website if the website supports it. So if you were to go to Facebook.com, by default, Facebook.com does not use SSL decryption to communicate with you. But with this turned on, it automatically restructures your communication to be SSL encrypted because Facebook will support it. They just don't turn it on by default. Well, that's a good question. Why didn't they turn it on by default? Wouldn't it make sense if they were able to do that piece? Well, that does make sense for them to do that. The problem is that encryption uses overhead. It uses additional CPU cycles on the server. It slows down the network connection because of that. I mean, there's delay as it encrypts and decrypts that data. Now, if it's just your machine, that's easy. We got plenty of cycles. If it's Facebook, you have millions of people hitting tons of servers that they have. There's additional overhead. So by default, they don't do that. Now, when you log in, they might log in using SSL, but then the regular pages go back to a non-encrypted connection. So looking back at that question that was asked earlier, if I'm in a coffee shop and I'm on the network and I'm communicating out to these websites, is SSH, or this SSL connection, is that something that's usable then? Well, to some degree, yes. It doesn't protect you on all websites across all pages, but hopefully those pages aren't any types of things that you'd be too concerned about somebody tapping into. The SSL to your bank, SSL to Facebook, SSL to other sites, you'll notice that does give you a little more privacy. The problem is that when you're surfing, you don't really pay much attention to that, do you? In fact, if you ever see messages pop up that say the certificate on this website doesn't look quite right for some reason, how many of us just naturally say, that's okay, keep going? We don't even think about it anymore. Get me to the website I want to go to. The browser's trying to tell you there's a problem here. In fact, the browser may be trying to tell you that somebody on the network is sitting between you and the encrypted site. They might be reading your information. Now, that's a problem. That's one of the things you have to look for in your browser, is that browser informing you that something isn't quite right. So perhaps if you're doing something that's very private in a coffee shop, if you need to go to your bank, if you need to log into your business emails, maybe you can't completely rely on this SSL connection to really provide me with the comfort level that I need to be assured that nobody can see what I'm doing. So that's a bit of a challenge. So let's look at a different kind of technology to be able to work through those types of issues. This is a technology called virtual private networking, or VPN. This is another important technology that you need to know for your Network Plus certification. So with VPNs, it works a little bit differently. There's some software that you load on your computer. So you're given the software by the administrator of the VPN communication, the VPN technology that you're going to use. So if you're in a large organization, there's somebody that runs what we call a VPN concentrator. And they've set up this concentrator with your login credentials, and they've provided you with some software that you load up on your computer. Now, when you go into the coffee shop, the first thing you do is start up that VPN software. At that point, an encrypted tunnel is created between your laptop and the VPN concentrator. And we call it a VPN tunnel because what the laptop effectively now is doing is taking every single bit of traffic that goes onto the network, and instead of sending it to CNN, instead of sending it out to Facebook, it first encrypts it all and sends it off to your VPN concentrator. Now, there are certain cases your administrator of the VPN concentrator can allow other outside traffic to go outside the tunnel, but let's deal with the situation that you'll most commonly find, which is your administrator has set up all traffic to go through this tunnel. This would be the most secure type of connection because nothing goes in the clear outside of your computer. Everything is in the tunnel. This becomes very useful. And the question in the chat room by Jonathan, is this concentrator something that you and your organization, you purchase? Is it something you do in outside? Maybe your ISP handles it or a third party. Different people do it in different ways. These days, VPN software or concentrator type software might even be built into the wireless router that you have in your home office. There are these SOHO, small office, home office routers, perhaps a little bit higher priced than what you would buy on the lower end wireless routers that you might put in your home, but some of those have VPN capabilities built into them. Other people will buy a big VPN concentrator because they might have hundreds of people connecting at once. The VPN concentrator might be built into the firewall that your organization has. There's so many different ways to package a VPN concentrator. I've broken it out and shown it as one box, and it can certainly be created as that. There are also a number of third parties that also do that, so that you can look for VPN providers, VPN service providers out on Google, and you get a huge list. And you go and say, I'd like to pay $10 a month. They'll give you software that connects to them while you're sitting at the coffee shop. And then once you are hitting the concentrator, everything on the other side of the concentrator is in the clear. So if you're dealing with a third party, there's still that potential that somebody on the other side of that third party might have access to it. But I think we all realize that's a much less of a worry than we have of people seeing it while we're sitting there at the coffee shop. So there's some very nice things that work pretty well for that. So this is a very good example of, well, look, when you work in a large organization, of exactly how you'd set this up. Now, one benefit of this, of course, is when it drops you off on the VPN concentrator, you are effectively now on the inside. You're on the inside of the connection, and it's like you're sitting in the office. You have the same rights and permissions to access anything that you would normally access when you're sitting in the building. So there's some nice functionality there. It's just extending that network connection from your building all the way into the coffee shop. And if somebody's in the coffee shop looking at your connection, they see garbage. They see encrypted links. They see nothing that's there. Now, one of the questions in the chat room is, well, what is that encryption there? Is that SSL? What is that? generally, most VPN concentrators are using a standard type of encryption technology called IPsec, which stands for IP security, IPsec. And they'll sometimes even start up the connection with SSL to make sure there's some type of encryption going back and forth. And once the login occurs, everything else is using that standard IPsec. And there's many, many different ways and many, many different encryption mechanisms that can occur in those tunnels. These are very complex tunnels that you would set up. In fact, you get a lot more of information about this when you take your Security Plus exam, but the technology itself is one that's very important to understand if you're planning to take your Network Plus certification. Now you've got a choice then. You can sit in a coffee shop and not use any type of encrypted tunnel and just go to your bank and hopefully make sure there's nobody in the middle and use that connection to your bank over SSL, or you set up an encrypted tunnel, all of your traffic goes into your corporate network, and now your corporate network, if you then have to go to CNN or Facebook or to your bank, is now using the corporate network's connection to the internet. So you're effectively using this big tunnel to the internet to get to your site, which is just going to go back to the internet again. And it sounds like it wouldn't be that efficient, but it actually is a very, very good way to encrypt your data, to protect your information when you're traveling on the road. I think that's very, very useful to be able to do that. One of the questions in the chat room, can you use the Tor browser like a VPN for surfing off a proxy? Okay, there's like three things. There are three types of encryption technologies and types of security technologies built into that question that was asked. So one of the things about that question is using a browser, and if you use a Tor is called the Onion router. It is exactly this type of tunneled encrypted connection. But instead of going to one single concentrator, everybody who uses Tor is participating as friends, or at least providing services to each other. You can have Tor nodes, and you hop to Tor nodes, which then hop to other Tor nodes, which hop to other Tor nodes, which finally on the other side bring it out at the end of the tunnel and decrypt it and drop you off somewhere on the internet. So that's one way of taking this VPN concentrator and distributing out the concentration of it and hopping you through a bunch of different links to finally come out on the other side. Now, that's one thing. It effectively is a VPN connection, and it's absolutely free. And it's worth trying. You really should download Tor. There are plugins you can get for your browser where you click a button, and now Tor is now enabled, and everything that you do is encrypted end to end. And if you're a coffee shop, you're tight on funds, you don't mind it slowing down a little bit because Tor is not the fastest configuration you will ever find. It often is very, very, very slow, but it is secure while you're in that coffee shop. Where it becomes insecure is once you hop off of the Tor network, and somewhere it's got to hop off the Tor network to finally continue on its way. So that's very, very useful. Now, the other thing on there was a proxy. And a proxy is a different kind of connection where I might be using an encrypted link or not an encrypted link to a third-party device, which then takes the link and extends it out. It effectively ends my connection and builds its own connections out to the rest of the internet. Proxies can be pretty useful for security, although they have their own challenges with applications being proxy aware or working properly with proxies. We're seeing proxy technologies are slowly declining as people are finding other ways like VPN technologies to be able to perform similar functions. Our firewalls are getting so much better these days with the way that they work. The proxies aren't being used as quite the primary security tool that people have used in the past. They're difficult to maintain. They're difficult to manage. It's a bit of a challenge to be able to do that. So the question in the chat room is, what are some examples of why a user would use some of these technologies? Well, if you have nothing that you have to worry about except communication maybe to a single server, you don't have to worry so much about privacy. Maybe SSL is one that you can use in a coffee shop and not worry too much about it. If you are working with sensitive data, you're working with medical data, you're working with corporate private information, you're working with an application you're developing, and you don't want anybody to have access to it, then you would want to use something like a VPN to make sure that nobody can see what's going on. That's and as they say in the chat room, it's very important things for work, or it's perhaps things you probably shouldn't be doing on the network and sneak around them. One important thing to consider is that if your organization has a VPN concentrator or they have a firewall, they absolutely have a way to decrypt this data and have a look at it. So you can't hide from everybody. Some of you think you're pretty crafty. You can hide that data in there. And at the very least, your employer can stop data like Tor from going out. So there's some places where you can't run Tor. They block it right there at the firewall. So you can't get around the security policies built into your organization, and nobody can steal that information to be able to get out. They can absolutely see those things. The stories I could tell you along those lines are pretty interesting. So there's a nice breakdown of some of those encryption technologies and how you would use them. Here's a question from Manuel. What is the relationship between the MAC address and the IP address? It's a lot of addresses there. Why am I doing IP? Why am I doing MAC? Why do I have to have two addresses? Is that really necessary? To be able to get a better understanding of that, we really have to step through the process involved at looking at the way the entire communication works from end to end. Why would you need a MAC address? And why would you also need an IP address? It's a lot of things going on here. So let's look to see exactly the way things work when you move back and forth over the network. Now I'm gonna change a few things on my screen here. Hopefully I can find something I can use to draw with here. So because I think it's very useful to understand when you are communicating out to Facebook or you're talking out to another location, it would be nice if you were able to understand more about what was going on. And I think that's one of the things that I run into when I'm working with my networks is how do I track it? Where does it go? How do I understand when I send out a request to Facebook, how does it even get to the other side? Is it using my MAC address or is it using my IP address? And that is the question that I'd like to cover here. So let's have a look at my screen. I'm going to bring up a view of a network diagram that I created, and we're going to step through that piece from end to end. Now, one of the things that you'll find when you start working with this is the MAC addresses become extremely important locally. Your IP addresses become extremely important end to end. And that's what you should think about whenever you're working with these is how does it operate from that side? Let me show you what I mean by this. Flip over to my screen here. Here's a network that I created. This is really not too complex of a network, but let me show you what's on the screens. There's a lot of things that I put on the screen for you here. So up on the upper left here is my workstation. So there's my workstation. And for each one of these things on the screen, I have put a MAC address for the device and an IP address for the device. Each one of these has them. Now, everything that's in the middle of the screen here, these square looking things with the arrows pointing on both sides, that is sort of an international designation for a switch. So if you ever see a diagram that shows arrows pointing in the same direction or opposite directions, that really is a switch. It's a layer 2 device. It's a network connection. It might even be a VLAN, but it's a way visually to look at this. And what I've done is stuck some little icons off to the side. So you can see I'm not the only one plugged into these switches. There's other people plugged into these switches as well. There's a switch here, and there's a switch in the middle, and there's a switch in here anyway. And of course, the switch is going to be taking information and sending it back and forth, and it's making its forwarding decisions based on MAC addresses. Switches don't care anything about IP addresses, have no concern whatsoever. Switches look at a destination MAC address, they try to find that in their list, and they forward it on to the right port on the switch. Now, these other round devices down here that have arrows pointing in and arrows pointing out, those are routers. Those are layer 3 devices of our OSI model. Routers don't care much about MAC addresses. Routers care about IP addresses. And they take information that's coming inside on one IP address, they're looking at the destination, they're figuring out what port would go to that destination, and they're sending it on its way. So already you're seeing some devices on my network very concerned about MAC addresses. Some devices on my network very concerned about IP addresses. But that isn't the reason why we have both of those addresses, of course. This is how we're really working with this. Let's follow a path all the way through. Let's start on this workstation. And we're going to start combining a lot of things that you have to learn for the Network Plus exam. So as we're stepping through this and you're thinking, I don't exactly understand why it does that, you may want to go back and look at that specific technology to learn more about it. So let's say that I need to talk out to the network. Let's say I need to ping an address that's out on 8.8.8.8. That's a good example I always use in my Network Plus stuff because 8.8.8.8 is the DNS that Google uses. So if I wanted to use Google's DNS, it's 8.8.8.8. It's just easy to remember. It's 4 8s. So it's a very easy one for me to keep in my mind. And it's pingable. Google allows you to ping it to see if it's up. So whenever I need to test connectivity to the internet, I type in ping space 8.8.8.8. And if it gets there, I can get to the internet. And Google's pretty good about their servers being up. So most of the time, if I'm getting a ping, I'm good. If I'm not getting a ping, I'm pretty much guessing that Google's DNS service is there. I'm just not getting to it. So that's some good things there associated with it. Let's follow the path. Let's say on this machine, I want to ping 8.8.8.8. Now, let's say machine has never talked to any other device on the network. I just turned it on. It's not done anything yet. Nothing is cached. It doesn't know anything else about the world. All it knows is that it has an IP address of 192.168.1.1. It has a subnet mask. In this case, it's a 24-bit subnet mask. And those of you doing the math, you know that it's 255.255.255.0. That's important to some degree here, but don't dwell too much on it. But what that really is saying is what subnet am I on? Now, another piece of information inside of my workstation that's very important is what is the default gateway? And in this machine, it knows that the default gateway is 192.168.1.11. Those things have automatically been configured on that workstation. So when I type in ping 8.8.8.8, it looks at the IP address I want to go to, and it says, how do I get there? Is that on my subnet? Well, no, my subnet's 192.168.1.1. 8.8.8.8, definitely not on my subnet. That's why subnet masks are so useful. That's why subnetting is so useful right there. That's that first decision your workstation has to make is this on my subnet? Because if it's not on my subnet, I need to send it to a router. I need to send it to my default gateway so that it can get out and do what it needs to do. Now, if it's on my subnet, if I wanted to ping 192.168.1.2, we would not even talk to our default router. Why would I talk to my default router? It's local. It's on my local subnet. But for our example here, let's say we're going to Google, 8.8.8.8. My workstation says, wow, that's nowhere close to me. It's not on my subnet. Let me talk to my default gateway. Now, before I can talk to my default gateway, which I already know is at 192.168.1.11, I just can't send a packet out to 192.168.1.11, can I? My switch doesn't understand IP addresses. It has no way to know what 192.168.1.11 is. So before I can talk to my default gateway, I have to figure out its MAC address. The fundamental communication on a network is always done by MAC address. The fundamental communication on a network is always done by MAC address. The first bit of information, if you're looking at an Ethernet frame, is the destination and the source MAC addresses. That's important information to look at. So before I can send it to my default gateway, I got to know the MAC address of the default gateway. But I don't know that. I just turned my machine on. It has no idea what that is. And so what my machine does, anybody know how that machine manages to figure out the MAC address of a device if all you have is its IP address? That's really a question for the chat room. Take a sip from my drink here, and we're getting the correct response. The correct response is in ARP. Notice how we're blending in all these technologies just to do a simple ping out to Google. So before I can talk to my default gateway, my workstation sends out an ARP, which is a broadcast, an address resolution protocol packet that says, hey, everybody on the subnet, hey, I just got here, and I got to send some information out, and I'm looking for a MAC address of a machine. The IP address I have of this machine is 192.168.1.11. So if you can hear me 1.11, would you please tell me what your MAC address is? 1.11 is, this is a broadcast. 1.11 obviously hears that and says, oh, well, I'm glad you asked. My MAC address is 11111111111. I made these very easy for us to keep in our heads. And it sends back an ARP response to that machine that says, if you ever need to talk to me, 192.168.1.11, just send those packets off to 11111111111. Great. Your machine receives that ARP and saves it. There's a cache on the machine that says, all right, that's important information. If I ever need to talk to this IP address again, I've already got its MAC address sitting right here next to me. Now it puts together a packet and says, great, I need to ping 8.8.8.8. I'm going to send this to MAC address 11.11.11.11.11.11 that has the IP address of 192.168.1.11. Off it goes. And now that packet finally gets off of my machine. After all of that, it gets off to my machine and it finally gets down into the router. Now in this router, there are two interfaces in this router, one pointing towards 192.168.1.11 and one pointing to 192.168.2.12. Notice this is the 2 network with the /24. They're different subnets. It's a router. We're separating out these subnets. That gets us part of the way. That's a lot of work just to get to that point. Now what happens to the packet? Well, now it's inside of the router. The router looks at the packet and says, I see that you would like to go to a particular address. Now, it's a router, remember. Routers care nothing about MAC addresses. Routers care about IP addresses. So it looks at the packet and says, well, forget the MAC address stuff. Where's this ultimately going? Oh, it's going to 8.8.8.8. Well, I'm looking at my router table. I know how to get to 192.168.1 network. I know how to get to 192.168.2 network, but I also have in these big tables of routes inside of my router something called a default route. And my default route says if it's not something I already know about, send it out 192.168.2.12 and send it out to the next hop of 2.15. That is exactly what happens inside of a router. That's all a router does. Receives a packet, says, where does this one go? Goes over there. That's it. If you are somebody who is the administrator of routers, you have to maintain where routing tables go. You mess this stuff up all the time. This is normal type stuff. You're running into routing table problems all the time when you're installing new equipment because you got to remember where's traffic coming from and where's it going to, and you have to build that routing table exactly right. If you're using a dynamic routing mechanism, you may not have to worry about it quite so much, but these default routes become pretty important on the way out. So now the packet's in the router. The router says, oh, you're going to 8.8.8.8. I'm not locally connected to 8.8.8.8, but I have a default route, and I know my default route says that I need to send this packet to 192.168.2.15. But I can't just send it to 192.168.2.15 because I don't know the MAC address of that device. So what does my router do to figure out what the MAC address is for the IP address of 192.168.2.15? It does an ARP. Does this look familiar, by the way? We're doing exactly the same thing we did on our workstation. Router sends an ARP out saying, hey, if 192.168.2.15 is out there, could you please tell me your MAC address? That router, along with everybody else in the network, sees the request, but only the router is going to respond up here because it's the only one that is 2.15. It says, oh, I'm glad you asked. I'm 15.15.15.15.15.15, and sends the response back to this router. The router then packages up that ping and says, here you go. I'm sending it off to that MAC address. Boom. It's all you from here. And the process happens again. That is now the same process where the routing table is looked up. You need to get to 8.8.8.8, sends it on its way. The ARP takes place. It figures out the MAC address, sends it off to the next hop, sends it off to the next hop, sends it off to the next hop, sends it off to the next hop. And to get to Google, you may hop through 13 or 14 hops just to get there. This happens 13 or 14 times just to get all the way to the end. And then what happens? Has to repeat it all the way back. So your routing tables not only have to be correct going that direction, your routing tables have to be correct coming the other direction. If you're ever in the place where you have to administer routing tables, this is the thing that people often forget. They'll get the routing tables perfectly correct going out and then forget to configure them properly coming back in. And the question, the chat room's like, gosh, that's a lot. It's amazing it works at all, isn't it? And it's amazing it works as fast as it does. But you're absolutely correct, chat room. This is all moving very, 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 very fast. Single packet out, single packet in, figuring out the ARP, sending that on its way, getting to the next hop, looking at the routing table, sending an ARP, figuring out the MAC address, sending it to the next hop, et cetera, et cetera, et cetera, et cetera, and on and on and on. That's why you have a MAC address and an IP address. And really, ultimately, the reason these are separated, imagine if a router had to keep track of where every single IP address in the world was located. Couldn't do it. There's no way to do that functionally. We're talking billions of devices in the world, tons of IP addresses. It'd be so inefficient. You'd have to say, send me to 8.8.8.8. Well, I got a big table here. Let me look through it. 8.8.8. Nope, looking through it. Big table. I'm looking. Hold on. Big table, 8.8.8. Oh, wait a second. I'm out of memory. I have no idea where 8.8.8.8. It doesn't work. There's no way to keep that in there. The same way, there's no possible way to keep a table of every single MAC address in the world. Can't do that either. That doesn't work at all. The router would have to be the size of Texas, as we're saying in the chat room. That would be an enormous router to be able to do that. And it would overheat. There'd be explosions. There'd be sparks coming out the side. You couldn't do it. That's why we keep networks segmented. That's why there are different subnets so that you can manage this process. And although it seems like a lot, just to make that happen. It works. How about that? The guys who designed this really knew what they were doing. They plug it in and the darn thing goes the right place and it comes back again. Now, the question in the chat room, well, you sent this packet out. It got to the router. How does it know how to get back again? Well, you have inside of that packet that's going are two very important fields. There's the destination IP address, and also inside that same packet is the source IP address that it came from. So by the time it gets to the other side, Google sees it. It looks up in there, well, thank you for sending me this ping. I will be glad to send you a response back. Let me look at the packet. Oh, I see your original IP address was 74.208 or whether it was something else on the inside. It knows where it came from, so it simply turns it around, sends it back the other way. And then all the routers have to do the same thing all the way back. And that is why we have IP addresses, and that is why we have MAC addresses to make that entire thing happen. Now, we'll also tell you that this entire story that we've done has been all about IP. But TCP/IP, hard to believe, was not very popular, if seen at all, on early networks. TCP/IP was not around when some of the first networks we used were coming out. The AppleTalk networks, the Novell IPX networks, the Banyan Vines networks. We did not communicate via IP. But the communication, the fundamental communication on an Ethernet network is done by MAC address. So on top of that MAC address, let's say we were using IPX. This is a protocol from Novell that's a layer 3 protocol, and it uses a completely different group of addresses to send information back and forth. It used a completely different mechanism to get data from one machine to the other, but it used a similar process. And what we were able to do was take that MAC address, stick an IPX packet inside of it, send it on its way. When it got to the endpoint, it pulled everything apart, and inside of it was IPX. So this MAC address allows us to send any information using any type of protocol over our Ethernet network. That's the value of having that data link layer, that basic functional hardware layer of the network, and where we're able to do those things back and forth. Very, very useful, very, very powerful. And if you start looking at network diagrams, you start looking at sniffer traces that you've made of packets going back and forth, and you start breaking them out. This is why Wireshark is so incredibly useful. You start breaking those out and looking at them. Look at all this information you can see inside of it. I see MAC addresses. I see IP addresses. I see port numbers. And now you can start to get a feel for how that data got here and where it's going, and start troubleshooting those issues. So there is a very basic breakdown of IP addresses and MAC addresses. Let's do our next question, which is, can IPv6 be made to look more easy to understand? Have you ever seen IPv6? I'm not sure I can answer this question. Looks tough on the surface. You're darn right it does. Chris is asking this. So that becomes a little bit of an issue, isn't it? You ever look at IPv6? It is a really complex thing. IPv4, we're just figuring out. We just figured out how to subnet IPv4. We just figured out subnet masks. I just explained to you IPs and how they work and ARPs and all those things from IPv6. Oh, now I got to break this down and have IPv6 breakdowns. This is pretty interesting though. And there's a very big reason we did it this way. And if you understand IPv4, you will understand that IPv6 isn't more complicated than IPv4. It is practically identical in functionality to IPv4. So if you understand IPv4, you are very, very far ahead of the game. One of the questions in the chat room, will this also be used for local networks? Will IPv6 be used for local networks? Absolutely. I was with an organization today that is a relatively large organization that is really active at implementing IPv6. And they're not a service provider. They don't provide network services for anyone, but there are some inherent capabilities in IPv6 surrounding security and other capabilities with routing that really interest them quite a bit. And so they're actively implementing IPv6, at least out to the internet and into their web servers. So natively talking IPv6 to the internet, very, very important for them. And a lot of people are doing this. It's not as unused as it used to be in the past. It's happening very, very quickly with this. Now, the challenge here, of course, is blending them together. And in the chat room, CoolCB asks if IPv4 and v6 can be mixed together. Absolutely. Because, of course, on an Ethernet network, the fundamental method of communication is a MAC address. And we're just layering on top of, you want to send IPv4 information? Dun, 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 dun. Yep, sends it back and forth. You want to send IPv6? Sure. We'll send IPv6 back and forth. Someday there'll be an IPv7. I don't know, maybe. Someday. maybe hundreds of years in the future, there'll be an IPv7. When that happens, we'll just do that as well. And that MAC address is always sent in every packet. Every packet on an Ethernet network has a MAC address along with it. Yeah, let's not force the IPv7. Let's first look at IPv6. We'll get our hands on this. So Internet Protocol version 6, again, layer 3. Now, if we're sending IPv6, this is not IPv4. They don't go in the same packet. You're either sending IPv4 or you're sending IPv6. So you got to make that decision when things are talking back and forth. So that's very useful to know. Now, these entire long groups of addresses that you see here are just this very basic, very fundamental IPv6 addresses. Very, very long. Look at how big these are. These are 16 bytes long. This is pretty long. So whenever we looked at what we were doing before with IPv4, relatively small. We're talking about expanding the size of the address out to be this very, very, very long address. And you can see that if you write them all out in binary form, look how long they are. Ooh, goes all the way down there. Very, very long to look at. The thing that I think makes people a little freaked out when they see an IPv6 address is there's no numbers anymore. There's not that base 10 mechanism to look at it. There's not a 192.168.1.2. There's those new numbers. Now we have hexadecimal. Ooh, hexadecimal. It's a bad thing. It's just different. It's nothing unusual about it. There's nothing difficult to see. In fact, it's almost easier to deal with it this way because if we were to write these all out as numbers, it would actually be a lot more complicated to see, and I'll show you why in just a bit. So if we're looking at an IPv6 address, there's all of these numbers. If we break these down into fundamental hexadecimal breakdowns, like for instance, this first 16 bits is FE80. That is the hexadecimal equivalent of those 16 bits there. So that's a very easy way to write that particular section of the IPv6 protocol. If it's all zeros, obviously it's going to be 0, 5D18, et cetera, et cetera, et cetera. So you'll never really see an IPv6 address written out with all the ones and zeros. I'm doing it here because you need to understand at the most basic level the function or how the construction is of an IPv6 address. But you never see these ones and zeros. You usually see something like this at the top, where you've got FE80, : 5D18, 652, CFFD, 8F52. That's not so bad. And when you're dealing with addressing and how it works, even 192.168, 1.0, a couple more on the end. A couple more numbers and letters there, but nothing you can worry too much about from an IPv6 perspective. Is it bigger? Yes. Is it a bit more complex to deal with? Yes. I'll agree completely that it looks a little bit crazy, but it's not overwhelming. It's absolutely reasonable when you start working with them. And when you start looking at seeing machines that are communicating to each other, very easy to follow and understand what's going on there. And you can also take these particular addresses and abbreviate them. So you don't have a lot of zeros inside of them. So you don't have a lot of numbers on the front. These numbers on the beginning of the address right there. It becomes a little bit easier to understand. Now I put down here also on the slide, your DNS will become very important, and it will become very important because you're not going to be able to remember 192.168.1.2 anymore. You're going to need to know a lot more numbers and letters to be able to get to those devices. So there is a little bit more work that has to be done there. Let me take you through, though, these address shortcuts we were talking about. When we deal with IPv6, let's say we took that raw IPv6 address we were just looking at. There's a lot of letters and numbers here. FE80, 0000, a bunch of zeros, CABC, C800, 00A7, 08D5. This is a little bit different than what we're just looking at. It's close, though. So let's abbreviate that. We do not have to specify an IPv6 address with every single one of these letters and numbers inside of it. We can abbreviate them. And the first thing we'll do is look at this and say, well, we can get rid of anything that's a 0 at the beginning of a particular string of hexadecimal letters and numbers. Because whether the zeros are there or not, it's the same thing in hex. So if we get rid of leading zeros, this is already looking a lot easier. So FE80, 000, CABC, C800, A7. Boy, we got rid of a bunch of zeros there, A7, and 8D5. We got rid of the leading 0 there. Very easy to see that. So if we stick them together, it's going to look a little bit better for us. But another thing that you can do, if there are groups now of zeros, and we can see there's 3 zeros right here in the middle that are just sitting there blank, they're empty. There's a grouping of them. There's 2 or more. that we can consolidate down, get rid of all the zeros, and just put a double colon right in the middle, which effectively makes it look like this. FE80 : skip all of this, CABC, C800, A7, 8D5. And when you now write it out finally, it's going to look like this. So there's an advantage you have already in working with IPv6 addresses, that you don't have to write them all out to be able to do that. You can simply look at it in a much more consolidated form. And the question that Bulletproof Mask asks is, well, you can't do it with one group of zeros? Well, no, because why would you? That'd just be a zero. You aren't improving things. You aren't getting rid of anything there. It's a single zero that's there. So it doesn't make sense to do a single group of zeros. It only needs to be two or more groups of zeros to be able to do that. Now, we didn't mention this, but a good question in the chat room is, can you take an IPv6 and translate it to IPv4 and vice versa? Well, that's a bit of a physics problem to some degree, and there's many ways that companies are dealing with this, because they may be talking IPv6 internally, but they may be talking to a machine that talks IPv4 only. How do you do that? It's not as easy as you might think. There are a number of technologies behind the scenes to make that happen. I can take an IPv4 address, convert it to hex, and put it inside of a much larger IPv6 address. That's a very common method for taking IPv4 and converting the IPv4 to an IPv6 address. And that's very easy. That's one way to go. You got plenty of room. You can do that. Very, very simple to make that happen. You can't take an IPv6 address, though, and cram it into IPv4. There's too many bits there. There's too many pieces of information that we need to worry about. So that's not going to work to be able to do anything like that. The way we work around this is you effectively create tunnels. You build out an IPv6 and you tunnel it inside of an IPv4 communication on the other side. And on the other side, it may break out that into IPv6, or you convert it, or you NAT it. There's a number of ways to get through some of these challenges with getting from an IPv6 back into an IPv4 environment. NATing generally is the one people are using. There's a number of other conversion processes as well that go outside the scope of Network Plus. The problem is that we're all trying to figure out the best way right now. And a number of the ways we thought we would be using early on with IPv6, we've abandoned, and everybody's gone to other methods. So one of the things that you'll see wherever you go and you're using IPv6, you need to get it back to IPv4. Generally, people are doing what we call 6 to 4, which is a method of taking that IPv6 and talking to IPv4 that way. And it depends on whether it needs to come out as IPv6 on the other side. We can just tunnel it through, or if it always needs to be IPv4, maybe it's a NAT that we perform, a network address translation, to do something like that. So that's very common to see those things in the way they operate to make that happen. It's a challenge. And if you are dealing with both of those protocols and you're working through how do I get back and forth, you have to make these fundamental architectural decisions early on so that you know how to set up your networks, you know how to find the equipment that's going to be able to translate it. And it's usually translated. Jonas Sin asks, how do you do that? How do you translate it back and forth? You would use equipment that's able to translate that, something that is an IPv6 aware router or an IPv6 aware firewall or some other layer 3 device that's able to make that conversion for you. Now, what about subnetting IPv6? Well, I had to draw the line somewhere. You absolutely do have subnetting in IPv6. That is a capability. That is absolutely something you'll need to know. It's a bit outside the scope for Network Plus, so I'm not including it this month to be able to do, oh yes, you got to do subnetting in IPv6. Sorry to tell you, absolutely got to do that. And it's a technology and a capability you still need, because you will still be given an IPv6 address by your ISP, and you will still need to subnet things inside of your environment. Can't get away from it. IP subnetting is going to be something you need to know in both IPv4 and IPv6. And the question in the chat room, converting IPv4 to binary seemed important. How important is it going to be able to do this in IPv6 with hexadecimal? It's going to be pretty important. And as you see in the new Network Plus certification, I don't know if there's a lot of hexadecimal to binary conversions that are required, but when you start working with IPv6 at a very low level, you will absolutely want to know how to make that happen. That might be a good one to add on as an addendum to the existing Network Plus materials. I think that would be very, very useful to have. I think people could really take advantage of some of that if you were ever going to look at that. And Chat room, yes. Subnetting. One of the questions I always get is about subnetting. I get many questions about subnetting every month. It is complicated. There's math involved. Just keep in mind from a Network Plus perspective, the amount of that you need to know for your exam on subnetting is this tiny, teeny little bit. When you look at the entire exam and everything you need to know, subnetting is a small amount of that. Subnetting is still valuable to know. Do not get me wrong. You need to know subnetting just day to day. But for the purposes of passing your exam, don't waste every single bit of your study time and pound your head on the desk because you don't get subnetting. You might get one question, maybe two questions on the exam about subnetting. If you only spent your time on subnetting, you'd be neglecting all of those other topics. Same thing with supernetting, those types of things. It's a small section of the exam. So work on it. It's important to know. You should know it. You should absolutely study it. Don't be too concerned about that. Now, looking at the clock, I see I'm approaching the top of the hour. That's too bad. I got a lot of stuff to go through. So we're going to keep going through it. We're probably going to go well after an hour, just so those of you who are watching live can be aware of that and set your clocks accordingly. I apologize for going long, but that's the way it's going to go with the topics and the things I have today. The next question, is there a guide to remembering cabling standard maximum different distances? Well, no, there's not a guide. There's no easy way to do it. There are some things we can look at with the way the cabling is handled and some of the distances. But some of this becomes rote memorization. You have to go in there and you just have to remember that on a gig Ethernet over copper, I can go this distance, and just keep listing them out. Those are good flashcard memorization. And the reality is, even though it seems like a lot of work to memorize this, it's something you will use all the time when you're doing networking. It's a very, very key piece of what you're working on. And somebody says, I need to go from that office down there to this office over here, a single run. Can I do it? Oh, well, what's the distance? It's 100 meters. Yes, you're doing 100 meg Ethernet. Absolutely 100 meters should work fine. We'll get the right category of cabling in place to make sure that we can go that distance without having any type of signal degradation. It's very important to keep that in mind. So what I thought we would do is look at some of the basic terms that we use when we talk about some of these technologies. So these are the ones we should keep in mind. So whenever you see a number in the front describing the technology, that's the speed. That's an easy one. So we know exactly if it's 10 base T, it's 10 megabit. If it's 100 base T, it's 100 megabit. Makes it very easy. If you see the letter T, it almost always is talking about using this technology over twisted pair cabling. So we already know that's not fiber. 10 base T is not fiber. Generally, fiber has other letters associated with it, and we'll talk about that in just a moment. If you ever see F, it's very often fiber, not always. Fiber sometimes has other letters associated with it as well. But if you see a number 10, that's the megabit, or 100, or 10G, you can 10 gigabit. If you see a T, generally always is twisted pair. If you look at 100 meg Ethernet, then there's two primary 100 megabit technologies to know. 100 base TX, 100 megabit base for the baseband communication that's occurring across that particular link. That means that we're using a frequency to communicate back and forth. Broadband is we're using many frequencies. We ever talk about broadband with cable television, they go, that's broadband internet. And that means that within that single cable are many, many different frequencies of signals going across that cable. Baseband, a single frequency that's being used to communicate that signal. So baseband, 100 base TX. Well, that's all. You can't read the slides, can you? Thank you, chat room. Chat room's awesome. See, I'm listening. I'm watching. Thank you, you jelly bro. 100 meg Ethernet, 100 base TX. So 100 base TX fast Ethernet, that's the 100 megabit. There's your 100 baseband. TX, it has the T, twisted pair. That's the important thing to remember with that. 100 base FX then would be F for fiber. So as we're looking at that, we're starting to get a better feel for these things. So if somebody said, oh, what 100 base FX, is that fiber or copper? You know immediately there's an F, there's fiber. Very, very easy. Let's take it up another notch. Gigabit Ethernet. 1,000 megabits per second, gigabit per second. That's where the 1,000 comes from. Baseband again. TNX. Now, here's where you get into things about fiber that aren't exactly the same thing. 100 base X here is gigabit Ethernet over fiber. And notice you have LX and SX. And although these terms don't necessarily stand for long and short, that's how we have become accustomed to referring to them. LX is a long wavelength laser that goes long distances, even 5 kilometers or more. SX, shortwave, about half a kilometer, and you're pretty good. So that's one of the things you run into, is being able to see the T and the X, and just keep in mind LX and SX. So again, some of this is going to be rote memorization, but it does help in the long run at looking at those things. Now, when you get into 10 gig, a number of different technologies. 10 gig has fiber, it has copper, it has different kinds of fiber. We're coming up with even new different kinds of fiber all the time that we can use with some of these. So the ones that you should keep in mind, though, are 10 gig base SR, LR, ER. These are all fiber. Whenever you get into these really, really high-speed technologies like 10 gig, I say it's high speed. Talk to me in 10 years about high speed. But today, 10 gig is high speed. So when we talk about 10 gig, almost always we are talking about fiber. Very, very, very rarely do we talk about doing 10 gig over copper, but we absolutely can. There is a standard for 10 gig over copper. But when we talk about SR, LR, and ER, we're talking about short range, long range, and extended range to be able to see that. So as long as you can keep that idea of short, long, and extended, you should be okay. But that's very, very common to see when you deal with 10 gig technologies. And I think whenever we start talking about these higher speeds and being able to do those things, it becomes pretty important to know that. When we look at some other types of connections, the question in the chat room, for instance, was about Sonnet, being able to look at some of these longer distances. Whenever we talk about integrating 10 gig Ethernet, sometimes we want to connect 10 gig out to other sites across the WAN, but we can't natively do 10 gig end to end, usually inside of very large rings in a city. They are running using something we call Sonnet or SDH. There's two different mechanisms used there. They are effectively the same type of technology, and they are ring type technologies that are used, and they're used over these large metropolitan areas to be able to do that. So you often see the 10 gig talked about as integrating in and having these distances, still using SR, LR, and ER, but very often we're connecting into a Sonnet, and on the other side, it pops out of the Sonnet and still becomes 10 gig again. Just keep in mind, if you're doing this over a WAN, probably isn't end-to-end 10 gig Ethernet. We're probably converting it. Your ISP or your network provider is converting it into Sonnet, sending it to the other side, and dropping it off on Ethernet on the other side. Why would they do that? You know, you got fiber down underneath. Why wouldn't you just send it 10 gig end to end? Well, Sonnet was specifically designed as a technology that would be very fast, fiber-based, and very resilient. It's built into these big rings. And if, let's say, this is a city, we don't have control of what happens under the ground or anything in the city. Let's say that somebody's working at a construction site, they've got a digger, they're digging down, and they break the Sonnet ring. They had no idea it was there. Yes, there's signs everywhere. Don't dig unless you call the phone company. This is why. They put down the bulldozer, it pulls it up, boom, it breaks the ring. Sonnet is smart enough, though, that all along the ring are these little end stations, these little segments. So the ring isn't just one big fiber, it's separate pieces of fiber. And if those Sonnet endpoints recognize, wow, we just had a break between us, loop the ring around. So that it effectively loops the ring around on itself. And now we've got redundancy. So anybody else on the ring sees no downtime. And that's why they put your 10 gig or any other mechanism, anything else you give them, they stick it on the Sonnet ring, it gets to the other side. You're paying for that redundancy and that resiliency. That's why it goes onto Sonnet. Sonnet's designed to do that. 10 gig Ethernet is not designed to do that. If I had a simple fiber connection in 10 gig Ethernet, I broke it, it would be broken. That's it. There's no ring. There's no way to get around it. So that was a little bit more than you need to know for Network Plus, but that's why we use Sonnet, and that's why we have to know what that's about. And if we do 10 gig, I mentioned over copper, there's absolutely twisted pair. You may see this done over twin ax, which is a coaxial type connectivity. You'll see that as well. There's different ways to do this. So 10 gig copper is becoming a lot more popular inside of the data center because copper generally is cheaper to implement than fiber. And because of that, it becomes very useful if you don't have to go half a kilometer, 5 kilometers, just plug in copper inside of the data center. Makes sense to me. So that was a quick overview, just something to give you a feel for some of the things you need to know about cabling and some of these topology types and why they would be used. But there's a lot of different kinds. And as I mentioned before, some of it is rote memorization. Other things we can kind of discern based on what those numbers and letters are. So keep those in mind. Don't worry too much about just this jumble of letters and numbers being thrown at you. Have a look at it. I bet you can decipher it and break it down without having to know a lot of the details of what's really going on under the surface. All right, I told you we got to have a subnet question, right? You got to. This one's going to be a little bit different. I did some subnetting in previous study groups, so absolutely go back and look at those previous study groups to really break down step by step exactly what you would do. But Gary asks this is other common question. Gary was not the only one to ask these types of things. Having problems with subnets, especially CIDR, CIDR. This whole CIDR idea is throwing me. It's got slashes and numbers. What in the world's going on here? Tell me more about why this is useful. Now, to some degree, we've already examined why subnetting is useful, but why do we use these CIDR blocks to be able to break these things out? And what I want to do is rewind all the way to the beginning of subnetting. And we're going to talk about why we ever came up with CIDR block addressing, because we never did this /24 when we first came out with IP. It is something we added on to this mechanism of subnetting after the standard had already been created. So let's have a look at that. That's a good point here. People will send me messages all the time that say, I was looking at your video, and your video has on it an IP address you were working with called 10.1.1.1, and its mask was 255.255.255.0. Well, wait a second. The 10 dot address is a class A address. That's the wrong subnet mask. Boy, and if you lived back in the days when IP addressing first began, you'd be absolutely correct. That was a class-based subnet mask option that was, or a capability that was required back then. Back when we first introduced TCP/IP, if you had an address that started with 10, your subnet mask always had to be 255.255.0.0.0. Always was that. In fact, we didn't even specify the subnet mask. Why would you need to write it down if it started with 10? We already knew what the subnet mask was. It was always 255.0.0.0, period. Done. If your IP address was 165.245.3.2, well, it would be a class B address, and it would have a subnet mask of 255.255.0.0, period. That's it. That's the only subnet mask that IP address could ever have, period. And we don't work like this anymore. We have the ability to specify whatever subnet mask we would like to whatever IP address we happen to have. So if somebody gives us an IP address, we can decide ourselves, how should we split up this IP address? How should we subnet this grouping of networks that someone has given to us? I'm going to explain this in just a minute. We're going to step through a scenario of that in just a little bit. So when somebody's looking at this and saying, hey, that's a 10 dot address, subnet mask is wrong. No, that is back during the class-based IP addressing. Today, we do classless interdomain routing, or CIDR, CIDR. Today, we have this ability to have flexibility with this. If everything was done on Class A or Class B or Class C, it had to have these numbers of networks and these numbers of hosts per network. So if you were given an entire Class C address, you could only have ever 254 hosts per network. But what if I only had 10 hosts at a site? Well, then you're wasting 244 other IP addresses. Wasted. It would be nice if I could take that site and make it a smaller subnet. Maybe other sites would have a larger subnet. Yes, it would be nice. But back in the original days of IP, you couldn't do that. Well, we realized pretty quick, well, that's not efficient at all. That makes no sense because we're going to run out of addresses pretty darn quick, aren't we? So we need to do something different. We need to have this so we've got flexibility. So instead of limiting exactly what the subnet mask should be to the IP address, we create an add-on, a designation that says, for this IP address, here is the subnet mask I'm going to use for this. And if you're configuring an enterprise router, if you're working on configuring an enterprise firewall, very often it is looking for you to define an IP address of an interface with CIDR block notation, which means I type in the IP address / the number of bits of the subnet mask, period. So that's the real key in this particular piece. So a /24, if you were to do the binary conversion of this, you'll need to go back to one of those previous videos if you need to practice your binary to decimal conversion, because this will be useful to you. But 24 bits all the way across would be 255.255.255.0. Each one of those is 8 bits. So 3 chunks together, 24 bits comes out to be that subnet mask. Similarly, if we had an IP address that was 10.1.0.1/16, well, that means its subnet mask is 255.255.0.0, and it would allow you to have 65,534 addresses per subnet. Now, very different than the Class A address that we were looking at earlier, which limited the number of networks, and you had this enormous number of hosts. Now you can segment it a little bit further. Probably still big for most networks. Here's a 10.1.0.1/26. The same IP address, but it's got a different subnet mask. Maybe we decide now, you know what? We don't need 65,534 addresses per subnet. I have a remote site. They're a very small site. I'm going to assign them a particular subnet that's pretty small, 10.1.0.1. That means their subnet mask is 255.255.255.192. And that also means that I can get about 62 addresses per subnet. When you take away the network address and the broadcast address, which would normally be 64 total addresses, you take those away, it's down to 62 addresses per subnet. That's the value of CIDR block notation. I can create subnets that are exactly the size I need, and I can make them, without wasting a lot of other IP addresses, make them fit perfectly into my addressing scheme. So when you're seeing that CIDR block, don't be too confused that it's not Class A, it's not Class B, it's not Class C, it's not Class anything. There is no Class A anymore. There's no Class B anymore. There's no Class C anymore. There are none. Now, it doesn't help that if you see a 192.168 1/1/24, this happens to me all the time, typing in an address, and I say, okay, I've got 192.168.1.1. What's the subnet mask? And they'll say it's a Class C. Yeah, actually, in the way we talk to people, the way we use that as sort of a shortcut. It's much easier to say it's Class C, or he could say it's 255.255.255.0. Wasn't it much faster just to say it's Class C? So we still use Class A and Class B and Class C in a colloquial kind of way to describe a shortcut of how that is set up. We don't really mean it's class-based. We don't really mean we're making this determination based on what the IP address is. We're just using it as a shortcut, which does nothing more than confuse everyone who's trying to figure out IP addressing and subnet masking, doesn't it? That's not very useful at all, unless you interchangeably using these terms to mean something absolutely different than what they originally meant. Sorry about that, but we do it. It's how we work here in the networking field. So don't be thrown by that. Just keep in mind that that's very useful to consider whenever you're looking at CIDR block notation. Now, how does this work in the real world, though? Why is CIDR block notation really that useful? Yes, I know that you're limiting, but limits are okay. And we got natting, so we're not going to run out IP addresses, are we? Well, we would have run out a long time ago if we didn't have this. This is something I grabbed right off Wikipedia. If you go look at CIDR block notation or subnet masking or one of those, I grabbed it right off of Wikipedia. It is a free graphic they give you. And the way this worked was that there was a network or an IP address that a device has. This device has an IP address of 208.130.29.33. But let's look at where that IP address came from to begin with. MCI was first given an IP address range that they could use to give to their customers, because MCI was a big company. They're an enormous company. They got lots of customers. So they got 208.128.0.0/11. Notice they didn't get the first 8 bits, and they didn't get a Class B of 16 bits. This is classless. So we cut into that second octet, and so they got 11 bits. And they were able now to take all of the other bits that were left and start divvying them out to their customers, just handing them out. They could cut them up however they wanted. One of the first things they did was cut it up into having a 22-bit subnet mask. a 22-bit CIDR notation there. And they said, okay, automation research systems, you provide other services to your customers. You're a big company as well. You're a company of MCI, but you've also got your own customers. Notice we got this layering effect. So for you to be able to give IP addresses to your customers, we're cutting off another 11 bits for you to do whatever you would like. And so we've now said here, now you're starting at the 22nd bit. You can now use the rest of these bits to subnet even further if you would like to. And indeed, they do want to. At Automation Research System, they have a whole section of public servers. So they cut off another 2 bits and allocated the 208.130.29.0 network /24 just for the public server arm of what they're doing. And inside of that public server arm, freesoft.org, which by the way does not have that IP address any longer, but at the time they did, they said freesoft.org says, hey, ARS, we need an IP address for their web server. Please give us one. They said, okay, on this network, this 208.130.29.0 network /24, you're going to have the address of 208.130.29.33. And if you are ever looking at the IP address of a device, it's very common to see the /32 at the end, which means there's no subnetting from there. This is the end address of this device. On this single device, it can go no further. And that is the IP address of that web server. Boy, that went a long way. But you can see now, by not having just Class A, Class B, Class C, you're able to cut this thing up and slice it up and subnet it in a lot of different ways to give you the flexibility that you needed to be able to perform whatever function you were doing. That's the value of doing CIDR block notation. That's why we do classless-based networking today rather than class-based to be able to have that work today. It makes more sense. It's much more efficient. And at the end of the day, it saved us a lot when we were running out of IP4 addresses. A lot of good stuff there. The Network Plus study group that we have today, a lot more things coming, a lot of other questions you asked about the exam itself, but I want to take a moment to thank our sponsors for the study group. This is GTS Learning. GTS Learning has A+ certification training. They have Network Plus certification. They have Security Plus and much more. All of their CompTIA certifications have been approved by CompTIA. If you look at most books out there, you'll notice most books do not have this certification from CompTIA. They took their materials, they handed it off to CompTIA and said, is this good enough to pass the exam? Is it something you can put your name on? And they gave them a big check mark and said, absolutely, this is CompTIA approved courseware. They have, of their Network Plus certification course, they have a sample download that you can have to try it out. And you can get that at professormesser.com/networkplusbook, Network PLUSBOOK. GTS Learning, Renee's asking in the chat room, is based out of London. So they are themselves the European arm of this. They also have offices in the United States as well. So it's nice to have that ability to go to their website and look at it. You can go out there and grab the Network Plus sample by going to professormesser.com/networkplusbook. And no matter where you are in the world, they have options there for you to buy it. They have a conversion tool right on their website. If that's something you like, that sample that you download, I want the whole book, you can go right there, click a few buttons, and immediately have that electronic copy downloaded to you. If that's something you'd like to have. And we certainly thank them for supporting Professor Messer and for supporting the Professor Messer Network Plus study group that we have every month. They're great guys. I visited them when I was in London. Fantastic folks to work with, and I really, really like their CompTIA study materials as well. They produce quality stuff. And I think next month I'll even have more exciting things to tell you. They're working on some really interesting things for online training that I've been talking to them about over the last few months. You're going to love it. Fantastic things that they're coming out with. Let's go through sample questions. I call this, or it's not sample questions, but questions about the questions. Questions about the exam. These are CompTIA Network Plus questions. And if you're ever wondering about Network Plus and how it operates, there's a lot of moving parts under the surface. So let's look at what some of these questions might be. You know, I've not answered one of these in a study group before. This is from Tim, who asks, I've never taken a certification exam before. I'd like to know the format of how this works. I want to know, once I walk in the room, what can I really expect to see? Is there something I should know about before I walk in? What's going to come up on the screen? How does this work? Is it multiple choice? Is it fill in the blank? Do I have a machine in front of me and have to put it together? What do I do? What happens here? Now, fortunately, it's all done online. It is all multiple choice. In some cases, you have to choose multiple answers on a question, but it will be very clear on the question how many multiple answers you need to have there. This is a common example of what it looks like. I took this from a sample exam, but it's one that is very close to being what you would expect to see. So you can see here, there's the number of questions you have. You have the time counting down in the corner, and I'll zoom it up so you guys can see this a little bit better. Yes, I will be glad to do that. In fact, I'll just do this. There we go. It looks a little bit better, doesn't it? So here's a question that came through. On the right side of this is a clock that's counting down. Now on here, you'll notice when you get asked the question, you can see it's saying the question is there and it wants you to choose two answers in this particular case. But the thing I wanted to show you is there's a box here that says, mark this question. So the mark this question that's there means that maybe I don't know the answer to this. Maybe I did answer this particular question. I'm not real comfortable with the answer I gave. So before I submit this to be graded, I want to go back to this, but I don't have anything to write with. Maybe I don't want to write down the question number to be able to remember which one it was. You don't have to. Just check the mark box that's there right at the top, and that mark box then tags it. And at the end, before you hit the submit, it shows you a summary of everything you've answered, what you answered, and there's an M next to it showing, hey, you marked this one. If you'd like to go back and look at it, just double click on it and you go back to that question. That becomes very useful. I mark a lot of my questions. This is something I use a lot. If I go in to a certification exam, if I know the question, I'm 100%. Absolutely, I got that question right, then I don't mark it. But if I look at that and go, I think I got it right, I'm 85% sure I got the question right, I mark it. I'm going to go back and look at it later, because what will happen, you'll go through the exam, and I'm on question number 3. You go through exam on question number 40 is something that jogs your memory about something that happened up in question 3. So if you, oh, that's right, I know the answer to question 3 now. And because I marked it, I can go back and quickly find it and look at it. So I go through the exam. Anything I didn't know 100% I mark. This is just my strategy. It may work for you as well. I mark it. And at the end of my exam, I got a lot that I marked. I got a big pages and pages of things I marked. I try to mark as much as I can. So that makes sense for me. I like to double check and make sure. So I've marked it all up. And now I can go back and see, did I get that one right? Did I get that one wrong? Then you've got to play that game with, I went with my gut. I still don't quite know the answer. But one of the things I found is that, you know what? I read that wrong the first time. They were actually asking for something completely different. I'm glad I marked this. Let me change my answer. If I still don't know the answer, I'm looking at it and you know what? I just don't know. And I've already answered it. I tend to keep my gut. I tend to keep exactly what I answered there. I don't usually change it. If I don't know, I don't know. And I answered it that way to begin with because of something. And I go with the universe on this one. The universe told me to mark that one originally. I'm going with it. Makes sense to me. Now at the bottom of your screen, let me scroll down a bit. Here's some options. You can, of course, previous and next, review and end, except you can't see that because my slide stuff is in the way. There you go. And at the bottom is review and end exam. You can end the exam right here. Yep, I'm done. End it. And if you're ever taking the exam, you hit the end button. It says, are you sure? Yes. Grade my exam. It tells you right then if you passed or if you didn't. It's crunch time. That's, sweat's coming down. All right. End exam. Yes. Click the button. Hope for the best. Get it in there. If you want to review, let's say I marked this question. I drilled down into it. Okay, I've re-answered it. If you go back to review, it brings back the page that lists out all the questions, what the answers were, and if you marked that question or not. So you've got that at least something you can work with whenever you're working on those exams and dealing with those pieces of it. That's what you'd expect to see during the exam. That's the process you normally would go through. So it is very useful to see that and work with it there. Another question, a very, very, very common question from Johnson V was, how do you know when you're prepared to take this test and pass it? That's another very, very common question. This applies whether you're taking the A+, the Network Plus, or the Security Plus. Maybe not so much with other manufacturers' exams. It applies to Linux Plus. It applies to all of CompTIA because CompTIA does a great job at labeling out, of explaining out every single topic you should know. This is pretty unique in the industry. Not everybody does this. Microsoft certainly doesn't do this. Cisco does this okay. But the CompTIA folks really go into detail. So what I do, I literally print out all of the exam objectives. You can download the exam objectives on the CompTIA website. Go to Google, type CompTIA exam objectives. Take you right to the page. And on that page, you can decide what exam objectives you'd like, and you can download them, their PDF files. Print them out. Print them out on dead trees, on paper. We're doing this for a reason. I don't usually print out things, but this is one time when I do. Print it all out, and then I sit down with a pen. Yep, I know that one. Nope, I don't know that one. Yes, I know that one. And when you can check off most of all of these bullets that are on the screen about all these different topics, you're good to go. You get about 85% of them done where you can check mark them, you're probably ready to take your exam. So it's a great checklist to use. And if you've gone through videos and you've read your book and maybe you've looked at sample exams or you've bought the exam cram books and you've gone through everything, now you're wondering, oh, should I call and schedule this? Or am I really good? Am I going to pass this thing? This is a great sanity check at the end. And if you don't know something, now you know exactly what to go over and look at. You can ignore all the other things. So it also helps focus you on exactly what you need to know. There's good stuff there to be able to see those pieces of it and to be able to work with it and be able to have it there available to you. Well, as I do on most of these study groups, I come across interesting things to work with during the week. And this was no exception. I have a link of the moment that I have here. You know, part of the Network Plus exam and the Security Plus exam too, and to some degree, some of the A Plus deals with working with wireless networks and working with routers and understanding them. And if you don't have a wireless network that you can work with, or you don't have a way to modify your existing network, some of these concepts might be difficult to understand. So there's a website out here that is skyangel.wiki.com/emulators. And what they have out there are wireless access point emulators for Linksys, Netgear, D-Link, Belkin, Trinet, Daytech, ActionTech, and Apple. These emulate a real access point with all of the settings associated with it, and you don't have to know anything. You don't have to have that access point live, and you're not changing somebody's live access point. Very, very useful to have and to work with. Let me pull up that site. Let's look at this really quick because didn't have it available on my screen. So let's pop up, open. Boy, look at all this junk on my screen. Let's do Google Chrome. Let's go to that page and look at it. I know this is, let me zoom it up so you guys can see a little better. So let's do one. Let's go over to, I have a Netgear router. So I'm going to go into Netgear. And their particular router is not listed. My router is not listed in this, but let's say somebody called you. Let's say if you're me, a family member calls and says, hey, you're pretty smart with computers and mine's not working. So please help me. And of course, anything for you, I'll be glad to. So what kind of router do you have? Oh, it's a Netgear and it says on it WGT624. Like, well, let me see the configuration of a WGT624. Let me click it. And here is the screen that you would normally have on a Netgear WGT624. There it is. So I want to know, oh, let's see. Go ahead and go down and click router status. Tell me what it says here. And just because you may be on the road or you may be somewhere you can't directly connect and do a screen sharing session with them, you can still walk them through all of those pieces to be able to understand exactly what's running on their particular networks. I just found that incredibly useful, especially if you're trying to find out more about some of these settings. You want to go configure access point configurations that would limit people's access to each other on the wireless network. So there's some interesting things there. Quality of service settings on some of these routers, settings for wireless encryption, they're all in there. And you can learn a lot just by going through those pieces. Some announcements before we finish up the study group for today. First, if you'd like to look at anything we're doing at Professor Messer, keep up with what's going on, or just drop me a note. You can find us on Facebook at professormesser.com/Facebook. Follow us on Twitter at professormesser.com/Twitter and Google Plus at professormesser.com/Google Plus. And gosh, guess where you can find me on YouTube? That's right, professormesser.com/YouTube. So very easy to find me if you need to get in touch with me. And of course, if you go to the website, there's a contact us link right at the top. Those messages go right into my mobile phone. I see them immediately, and I can't answer all of them that come in, but I certainly try to get back to as many people as I possibly can. Want to thank again GTS Learning for sponsoring these ongoing study group sessions. I think I got a lot of really good questions from you guys. I love giving this back to you. And of course, they're always available for replay anytime you'd like, directly from the website that we have at professormesser.com. And of course, thanks to all of you. We couldn't do these study groups without these fantastic questions that you send in every month. And as you're going through the month, you have an idea about, here's an interesting question that would be great for a study group. Go to the website, click Contact Us, send me a message, and let me know what you found or where it is. Or if you find a really interesting website like the wireless emulators one, go out to that one, send me that link. I'd love to add those into this as well. It just helps everybody else as well to be able to do that. Well, that covers everything we went through. My 60 minutes of a study group this week went into 90 minutes. So that's not too bad, but at least I think we got through a lot of your major questions for the month. I'm really glad we could do this month. I'm already looking forward to our study group next month. Thanks again for joining us, and we'll see you next time on the Professor Messer Network Plus Study Group.